Thank you all so much for being here. I know it's already the end of the second day, but on behalf of NumFOCUS, thank you so much for coming to PyData London. We really treasure this community as one of the most vibrant PyData communities, and as this is the 5th year, you know that's been going on for quite a long time. So I'm going to take a minute to tell you a little bit more about NumFOCUS. Here is our mission, although you perhaps know us best as the sticker people. And so I want you to know us as more than the sticker people, right? We were founded to be a foundation that would serve as an organizing rallying point for open source scientific computing projects. And when you hear me say projects, I'm talking about the software tools that you all use typically every day. And those tools are used everywhere from Netflix to NASA to build a better world. So I know you all are tackling very cool and interesting challenges, probably on a daily basis with these tools. We have 22 sponsored projects at NumFOCUS. What is a sponsored project? What do I mean when I say sponsored project? Essentially, one of the programs of NumFOCUS, which is arguably the heart of our mission, is what is called a fiscal sponsorship program, which is just fancy words that mean an open source project comes under the umbrella of NumFOCUS, and now NumFOCUS is the legal entity of that project. And that's valuable for a variety of reasons. It helps projects attract funding, provides greater stability, independence, and logistical support. We also provide a variety of services to the project, so you can have something like, for example, NumFOCUS is the holder of a trademark, which you might not want a private company, for example, to hold for an open source project. We do all of these wonderful things on behalf of them. And we also organize a number of programs to grow the community. So we have Google Summer of Code. This year we have 45, I think, students participating. We have the DISC program, the Diversity and Inclusion in Scientific Computing. You can come chat with us tomorrow at the roundtable about that. The John Hunter Matplotlib Summer Fellowship. That is currently accepting applications, so if you are or know a student who would be interested, that's open until May 6th, I believe. More information on the website. And we also provide a number of grants and scholarship funds. And let's not forget, PyData is an educational program of NumFOCUS, where all over the world has grown so quickly. And I might also point out there's 98 groups, so if 2 people in here want to start a group, that'd be awesome. Okay, and talk to Jim. I'm not sure where he is, but he'd be happy to chat to you about how to get it kicked off. So let's do the interactive portion. Please raise your hand if you use at least one of these projects every day. Pandas, NumPy, Jupyter, Matplotlib, great. Love it. Keep your hand up if you have contributed back in some form or fashion. Let's applaud these people, please. Thank you. This is so incredibly important. It is really the heart of what I want to talk to you about today. So this is true all over the world. There is a meaningful sustainability challenge for these projects because they are so great. They're very, very popular. If you just look at the growth of the number of Jupyter notebooks that were hosted on GitHub, now we're over 2 million in the course of 3 years, right? Check out the orange, green, and purple lines here. This is a growth in questions asked about NumPy, Pandas, and Matplotlib on Stack Overflow. So obviously lots and lots of interest in these projects, but they're not receiving in return the kind of resources that they need to hold up sustainably under this demand. So the majority of the handful of maintainers who take care of these projects are not even paid to work on the projects full time. And when you think about that, it's really sort of awe-inspiring what they have to hold up under. So what NumFOCUS would like is for all of us to be able to have really stable, comfortable stream of funding coming in to support those folks. And so that's the role of NumFOCUS in many ways, is to connect these projects with stable sources of funding. PyData is among those. So for example, funds that were generated from the PyData London conference last year helped to send some of the project leaders to the NumFOCUS Summit in 2017, which is a gathering of industry, academic, and project leaders together to talk about the future of the ecosystem. So thank you, and thank you to Bloomberg, who has been our host for a number of years, for making that possible. Just to give you a sense of it, Because of PyData, we have been able to bring in more than twice as much money as what corporate sponsors directly donate to NumFOCUS to support the projects. So that's because your ticket is technically a donation, and all of these wonderful sponsors have sponsored the PyData event series, and that has enabled it to generate that funding that goes to support the projects. So what I want to challenge you all is that if you use these projects every day at work, your company should be a sponsor of NumFOCUS, right? So let's have some of the amazing gains that have been achieved as a result of using these projects go back into supporting the projects. So when you leave the conference, talk to your boss and find out how they can get your company to be on board as a NumFOCUS corporate sponsor or as a sponsor of a PyData event. And in the meantime, you as an individual can contribute, and many of you have, thank you so much, to the projects in a variety of ways. You can contribute code. Please check out the Pandas Sprint tomorrow morning. So cool and exciting. Hopefully you heard about the Worldwide Pandas Documentation Sprint. That was really fantastic. You can read about it on our blog. Keep an eye out for opportunities like that. It feels like a big jump to get into your first open source contribution, but there are people in this community who are there to help you make it, and it's so important. You can contribute time. It doesn't have to be code. All the people in orange shirts here who are volunteering and helping to put the PyData together is really making a great contribution. And for those of you who would rather pay for your time with money, you can do that as well. We accept donations to NumFOCUS that go directly to the projects in the form of memberships, and you can find out about that more on our website. So in conclusion, if you use these projects, if you love them, help put them on a sustainable path, find a way to get involved and give back so that we can rebalance the load a little bit from everyone using the projects but not contributing to everyone using the products and contributing. Thank you very much.
Okay. First, as you might know, EuroPython is coming to the UK this year, and we're going to this beautiful, yes. And we're going to beautiful Edinburgh. As you know, PyData is strong with EuroPython. We have a PyData track at EuroPython. We do that together with the local community. Like, you know, Nick, he's from the local community in EuroPython. So we're a little bit late setting the conference up because we some tech stuff. Don't worry about it. The call for proposals will open next week on Monday. Tickets will also go on sale soon. So reserve your hotels, get your budgets, and just follow EuroPython. We have a different conference layout this year, so it's not 5 days of talks anymore. It's only 3 days of talks, and the trainings are before 2 days. So it's a little different. And yeah, so hope to see you all and your great proposals for EuroPython. And this brings me to the next conference, EuroSciPy. And if you see this picture, you know you already want to go there, actually. Yes, and the only way is it's in northern Italy, in Trento. It's the 11th EuroSciPy, the scientific Python conference. The dates are from August 28th to the 1st of September, somehow. And good news, the call for proposals is already open. So see your proposals there. And last but not least, and you always wanted to come to Germany in October, there's the German Python conference with a strong PyData track. If you don't have heard of Karlsruhe, it's in southern Germany. This is where the heart of engineering is, like Bosch, Daimler, Porsches. They're all here, and this is so also AI is strong with us there. So call for participation will open next week, and yeah, I hope to see you there. And one spoiler alert: if you really love pandas, you should really come there. And yeah, that's it. Thank you very much.
I don't know, Jim, Vincent, did you want to say something as well? Or are we quick?
Yeah. Matti, are you in? Matti? Already at the pub.
Already at the pub.
Already at the pub.
Wow, I'm used to being behind the scenes, not in front of the stage, so this is great. But it is, what's that?
display settings.
Can you do it?
Keep talking about it.
Yeah, so I was just going to say it's great seeing everyone because I do email and get the privilege of slacking and communicating with a lot of you guys. So being at the conference has been great to actually put some faces to the names and email addresses that I've been with. As an introduction, my name is Jim Weiss. I do the events coordinating and the PyData support for NumFOCUS. I'm the most recent addition to the team. I've been on board for about 6 months now. So if we have been emailing, I haven't got a chance to talk to you yet, please stop by and introduce yourself, and I look forward to doing that. I guess I wanted to come up here mostly to introduce myself and to say that I kind of see my job as trying to support the local PyData communities as much as possible, because the communities themselves they're locally led. They're led by people who are volunteering their time. So anything that I can do to make your lives easier, that's my goal, and that's what I'm trying to do. And so if there's anything we can do, if there is a community that doesn't have a PyData presence yet and you want to be a local leader and organizer in that, you can email me. If you have a local community that maybe does meetups and wants to venture into doing like a day workshop or doing a conference, please email me again. If you just want some stickers, you can email me. So yeah, that was probably my main take-home message, and just to foot stomp some of the successes that we've had. As you saw, we're up to 98 communities in the world, which is great, and it's continuing to grow every day, so please continue to support that. Florian kind of mentioned earlier, this year, numbers are still pretty early in the ballgame, but we're looking to maybe bring in about $80,000 to $100,000 in donation to NumFOCUS, so that is really great, and appreciate you coming and purchasing a sit ticket and continuing to support. So thank you for that. And we're trying to continue on those successes with a couple of upcoming events, which is why I have Vincent on the stage, because PyData Amsterdam is the next large-scale PyData conference that we have in May from 25th to 27th. So I will let him explain that one.
Yeah, come to my conference.
Thank you, Vincent.
Okay, I also feel kind of obliged to speak on behalf of Matti. Last year was a little bit crazy for me. I went to like 5 PyDatas. Part of my goal was to help connect everyone. One thing I will say, genuinely, this is a great conference. There are many great conferences. And what you will notice, if you go to all these different PyDatas, they each all have a different vibe. So if you go to Berlin, it's very proper maths, it's kind of academic. If you come to PyData Amsterdam, it's a bit more smoke and a pancake. If that sounds like the thing you might like, come to my conference. But definitely check all of them out. They're lovely places. They're a great excuse to travel with your partner, by the way, if I can just suggest that. But do check them all out. I mean, they're all worthwhile, definitely. Even the one in Amsterdam.
Cool. Thank you. Yeah, so we expect to have PyData Amsterdam again this year and PyData Berlin. In the U.S., we'll likely have PyData New York again in the fall. We're probably going to have our first time PyData LA in the fall as well, first time in LA, and looking to maybe do a PyData DC also in the fall. You can see we're going to probably do PyData Cordoba and Warsaw again, and many more. So continue to check PyData.org and see as the events get scheduled, and we hope to see you there for all those. And the other kind of event I also wanted to mention, as Gina did as well, was the different sprints and other kind of opportunities that people can engage in. And actually wanted to invite Mark up if he's here and wanted to kind of talk about the latest sprint that we did, because it was a pretty cool thing.
Yeah, thanks, everyone. I don't know if you saw that. It was a bit, quite a bit of a big thing, I would say. Like we've got the Pandas Sprint. It was a worldwide event where 30 different cities, around 500 people were contributing to Pandas, the Pandas documentation. How many people was participating? I see just like some hands, yeah, a few of them. That's pretty cool. And we managed to fix around 300 pandas documentations. In the next release, you will see the results of that. It's like when you go to pandas documentation, instead of having a single line saying the head method return the head of the data frame, you will have some sort of examples and things like that. I just want to show you a few pictures. I think that's better. That was from Nigeria, from Lagos. That was in Paris. That was the group in Delhi. They did a lot of nice stuff on the string functions. That was in Chicago. It was really an amazing experience. I think it's a really good thing to go from being a user of all these tools to being a developer, even if it's a very small contribution, something like a docstring. Actually, I said it's small, but in 6 hours, very few people could finish them, and actually it was much more work than at home. If you're interested on that, you want to discover and you want to get, become a Pandas contributor and not a Pandas user, tomorrow we're running this sprint. It's just like some introduction, so if it's something that scares you, I think it's worth taking the opportunity to not feel scared anymore and understand that it's something really, really amazing to be part of. Yeah, thanks, Jim.
I was just saying that's about it. Email me if you have any questions or any requests, and I'll see you at the events. Thank you.
I would like to talk about dirty categories. So, machine learning basically models data as numerical matrices. Real life doesn't. Sad cat. The problem I'm interested in specifically is this column here. What do we see? We see things like overlapping categories. If you read those categories, you know that there is shared information between this. In real life, we will have very high cardinality. The specific data set has 400 unique entries and 10,000 rows. With rare categories, we have only one architect 3. And what happens if you have a new category in the test set? So this happens in many data sets in the wild. This is a plot that shows the evolution of the number of categories for a bunch of different data sets with the number of rows. So basically, they go up. The graph shows it. I'm a scientist. So our goal is to do supervised learning on dirty categories. And the intuition behind this is that we shouldn't curate this data because the statistical question should inform the curation. Basically, I have a data set where I have those two corporations. Are they the same? Yes, no. Is this morphological variant? Yes, no. So there's a bunch of different related approaches. In database cleaning, people will call this a deduplication record linkage problem. In natural language processing, we'll look at this as a semantic problem. This is not something word vectors will capture on Wikipedia, by the way. And in machine learning, there's a bunch of different problems related. And I'd like to connect to CatBoost, which is a fantastic library that has related solutions to what we do, only related. So what we're proposing is to look at to adapt one-hot encoding to look at the similarities between strings. Okay, and we've worked at this in a submitted academic paper where we're looking at a bunch of things, and there's going to be more work theoretical. And so really the idea is you look at one-hot encoding, but instead of putting ones and zeros, you're going to put a similarity. Okay. And this doesn't solve everything because you still get a matrix that tends to grow, and you need to compute this fast, but we're working on this, and all these problems are solvable. So one of the problems is the dimensionality that increases. So basically, you can do things that are related to random projections to make this not grow and limit the dimensionality. Or you can take in your dictionary only the most frequent categories. There are different ways of doing this. So what we're going to be working on next is using a trick that's known as hashing, which is a common trick when you're trying to count things, and specifically hashing n-grams to basically do random projection with speed. All right, this is all nice and good. So my goal here is to tell you that dirty categories are a thing, that we should be doing statistical modeling on non-curated dirty categories. I want you to give me your dirty data because I want to include it in my benchmarks. We're proposing a simple solution that's called similarity encoding, and we're proposing software, which is research software, right? It is not production software, but that you can try and contribute to. And that's all I have. Thank you.
My name is Jordi Contestí, and I'm one of the 10 organizers of the fantastic PyData Mallorca meetup. And just in case today or tomorrow or in the future you want to start a new PyData meetup, let me give you my personal recommendations. First one, please do not worry if you are a beginner in data analysis. Thank you. So it's not necessary to be a great expert to start a meetup, so keep that in mind. Second, remember that you will be a volunteer, and that means that instead of watching the last episode of Game of Thrones, you will be preparing, worrying, and organizing your next event. Keep that in mind, too. Do not forget about networking. Networking is the key of the success of your meetup. Why? Because networking will allow you to find organizers, to find speakers, sponsors, members, volunteers. So you have to work with networking. Organization is easier if you are not alone. So first task, look for other organizers to help you with the meetup. And that's very common. Most of your members won't know anything or very little about data analysis. So expect to teach them the basics, okay? And the most important one, enjoy the experience. It's a great experience, and learn from it. You will learn a lot how to organize events, and you will learn a lot about data analysis too. And well, that's all. That's my meetup. I hope you can go to Mallorca someday and give us a talk or attend our meetup. Thank you very much.
Yeah, hi everyone. My name is Tina. I'm a data scientist, work in Telenor, and I've just thought that this would be a nice place to share some observations about a little simulation study that I've done, and it's about model consistency and something quite boring, which is different versions. So I'd like to start just out of interest. Who knows what, from the top of their head, what model version they're currently using in the library? So say sklearn or H2O or whatever your preferred thing is. So there's a few hands going up. Next question would be who, if they update regularly, reads the release history? Yeah. Not so many hands, and I think that's quite natural, and it kind of shows the comfortable position that we're in, because we have wonderful people developing all this cool stuff and making it available for us free of charge. But it's also, there is a risk behind it. So what if you upgrade and suddenly your model results change? And I was recently in the position, so I just reran some older code, and nothing had changed, not the data, not the script, nothing, but my model results had changed. So I got kind of interested in this slightly hygiene kind of aspect, because, yeah, there's a lot of developers who focus on efficiency, and I wanted to know, well, how much of model consistency are we actually sacrificing maybe for some model efficiency steps? So I did a little simulation study, because that's easy to do. You just take all the, so here I've taken gradient boosting libraries, and I've looked, I've basically taken all of the versions that you've got, and you have a little script which loops through all the versions, and whenever they install, you run a baseline gradient boosting model for scikit-learn, XGBoost, LGBM, LightGBM, H2O, and CutBoost. So those are the most popular ones, which I guess most of us are using at some point. And then I just compared the variance of the estimates of that default model. So I didn't actually invest any time in tuning the models, but that's not necessary for showing the point here. So if we are just looking at comparing the classification results and regression results, so I compared mean absolute error for the regression case and F1 score, because that's easiest and implemented everywhere. And if you just look at, oh, you can't see anything. So here you see how the model evaluation changes as you change the version. And as you see, it's a quite stable picture. However, yeah, you see some indications that for LightGBM there's something going on, and for sklearn there's something on. So let's look into the actual underlying data points, which are this. So here you see the regression results, mean absolute error, and you see each package, and I'm just looping through all of the versions, and I'm plotting the accuracy, mean absolute error here, F1 score here. And yeah, what do you see? So you see for the regression case, sklearn and XGBoost is best. Cat boost, not so well for some reason, but I wouldn't overinterpret these results because these are just default models, and I'm really interested in, if I change nothing, so other things being equal, how consistent are my results? And you see the same for the F1 score, and something very interesting is that there's something going on with LightGBM, and that's also the package where I found some differences. And I was not the only one. I found a lot of GitHub comments. I found a lot of comments on Kaggle. So if we zoom in here, now on the x-axis, you actually see what each of the versions were. And so for the classification case, there's something going on where the F1 score drastically improves between version 2.04 and 2.05. And then it drops again, and then it decreases again. And you kind of see the similar development for the regression case. And yeah, I just got interested in what's going on here. I really like the package, I have to say. It's extremely fast, it's very scalable. And I do want to use it, but as a user, I have to understand these things. So I got interested, and I actually did a little bit of detective work. And on the GitHub commits, there were two reasons that they were investigating. One is the treatment of NA variables. So in one version, it was treated as 0. In the other one, it was treated as a separate category, modeled completely separate. So I tested that, but that doesn't make any difference. So that's not it. And then there were also some comments about the max bin and how that is treated in the algorithm. And there were actually quite some substantial changes which were moved out of the Python process into a C preprocessor header file. So it's a considerable change in the execution. And I think just this is kind of an example of one of the, where we should refocus on this testing. So somebody's made some good development, but how do we test it? And this quality assurance, so we have brilliant open source development, but we also want brilliant open source development testing. And I'm kind of proposing here, well, why can we not, why do we have to write all of our tests ourselves? Why do we not have an open source benchmarking environment for testing all the performance against the same data set, and not just Iris or Boston house pricing, which are very correlated data sets? But why don't we have an open source development for continuous testing, where each deployment can be tested against the same benchmarks? I think that would save time on testing, so each of the developers don't have to do that themselves. So it would speed up development, and I think it would also help spread the usage of open source packages in enterprise. So yeah, thanks.
So I'm Oliver Price. I'm a master's student at Warwick University. So I'm going to talk to you about my dissertation, which has the title Detecting and Clustering Fact-Checkable Claims. So some of you who went to Lev's talk this... so those of you that went to Lev's talk this morning, you might be thinking that that looks quite similar. And that's because it is. Lev's my supervisor. So hopefully, hopefully I can bring some stuff that wasn't in Lev's talk and provide some more information for you. So it's in collaboration with Full Fact, which is where Lev works. And Full Fact are one of the UK's leading fact-checking charities. And their job is to essentially take claims that are made on television, in debates and on the radio by politicians and other sort of influential figures, and check the facts behind those claims to make sure that the general public are well informed about what they're reading and listening to and hearing. And that's really, really important because, you know, otherwise the spread of misinformation ends up happening and going around the general public. And when the general public are misinformed, they make misinformed political decisions, and that kind of messes with democracy somewhat. So it's really, really important, the work that Full Fact are doing, and I've become really passionate about it since doing this dissertation. So I've mentioned claim, but what actually is a claim? Here are some examples. So unemployment dropped by 2% last year. That is a claim. Someone's claiming something, and the fact can be checked relatively easily. Under the Conservatives, homelessness is at an all-time high. Again, it's the same as the previous one. The lady would like to ask a question. Now, this is kind of a tricky one. So it actually is a claim, but in the context of fact-checking, it's not a claim. You can't check the facts behind that. But grammatically and semantically, it's similar to the first two examples I gave. And the other one is, it is my opinion that immigration is bad for the economy. That's someone's opinion. By the way, it's not my opinion. That is someone's opinion. It's not a claim. So in order to do the fact-checking, there's a clear process. It's obviously, a claim has to be identified first and foremost, otherwise you can't fact-check anything. The type of claim needs to be found, so they know where to look when doing the fact-checking, and then you need to identify the popular claims so that you know which ones should be fact-checked. And then once this is done, the facts are checked, and a really detailed report is put online for the public. So this box here is my project, and I'm looking to automate the sort of pre-fact-checking process there. So this is the overview of the methodologies. Going to be identifying claims, binary classification. Then there's going to be a multi-class classification of the type of claim. And then we're going to be using clustering and paraphrasing techniques to find out the most popular claims as well. So the progress I've made so far is purely on the claim detection side of things. So here's some results. We use stratified K-10-fold cross-validation on all of these. So yeah, just a variety there. Just various sort of logistic regressions with TF-IDF, and we've used embeddings as a transfer learning task because we've got quite a small data set. There's only about 4,000 sentences. These results are okay, they're not bad, but the best result so far has come from a method called inversent, which Lev presented this morning in detail, but essentially it's word embeddings are generated using a natural language inference task inside a bi-LSTM neural net. And we've produced, these are really good results, 92 precision and 87 recall. After Gail's talk yesterday, we went back and had another look at it, and it actually turns out that there's 5% either side of the recall, so it's not always 87, it can be less or more, and 2% either side of precision. So what's next? That's what we've done so far. Up next is going to be basically finding out these popular claims, and we're going to use some novel paraphrase detection techniques and basically form clusters of similar phrases which are the popular claims because they appear more often than anything else. Thank you very much.
I wanted to talk briefly about something I did to share. Maybe someone else also will have benefit from using that. I wanted to experiment with those word embeddings you hear about. Because like the ideas that I had involved small data sets, just like Oliver was saying before me, and yeah, like you can read. Basically, when you browse the internet to look for pre-trained word embeddings, you can find many generous companies and people post their stuff. And for example, FastText. When I go to FastText, I can go to download models, and then they have word vectors for many languages. And when I want to use that, it essentially turns out to be a very long file with the word and the vector. And if I want to load that to Python, either I have to read the whole thing or I have to load it into one of the models. Like, for example, FastText expose they have Python bindings for their solution. So if I use that, import FastText, and I wanted to show you that I downloaded the model earlier, and I had the zip file is 500 megabytes, and the unpacked thing is 2 gigabytes, so it's quite a large thing. And then if I want to do a model equals fasttext.load model, and then I'm going to give the path word to vec, and then wiki. Then what I'm going to see is I'm going to see this dreaded star here for nearly forever. And
And then if I go to activity monitor, I'm going to see an ever-growing memory consumption situation regarding loading this file. I tried it earlier this week, and it ballooned to 40 gigs, and then I had to kill it. So I can let it run. And so I developed something that basically takes other people's work and packages nicely to solve this thing. And I posted it on GitHub. And this is essentially word embeddings are keys mapped to values. So I use LevelDB as a disk-based key value storage, and just like a Python binding developed by a gentleman from the Netherlands who generously also published this package, and it just wrapped it nicely so you can download Glove, you can download whatever else, you can read a zip file and create this LevelDB indexed database, and then just look it up as you please and stick it into a Keras layer or whatever you're trying to do. So it's called mstore, so I'm just going to do import mstore and then do e equals mstore, and then just specify a path to the place where I created this. So again, home or to vec, and then ftwiki, and that's it. And it's open, and then I can do e, and then use what's my favorite word, whatever, cat, and then I have the embedding. So it uses struct pack and unpack to make the array of floats into a very condensed bytes situation, so just to save space as well. So the LevelDB story is just as big as the zip file initially, so it just takes half a gigabyte for this particular situation. And the way you create it is you can do mstore. Okay, game over. You can just do mstore create, and I'm going to post on Slack the GitHub address. Oh, okay, sorry. Good idea. Yeah, so these are the embeddings, but if you do create embedding database, you just do the zip file origin, and then the destination where you want to write the LevelDB database, and it does it in for this file, it does it in a minute and a half, and then you're good to go for every restart of your kernel. Whatever happens, something breaks, you never have to wait 5 minutes for the thing to load into memory. Yeah, I find it helpful. It doesn't do nearest neighbors, but it does reading fast. So thank you very much. And
Hi, I'm Nick Radcliffe. This is going to be super fast. You all moved to Python 3 anyway, so it's irrelevant, but in case any of you haven't and happen to have large code bases, a couple of things we learned actually doing it. It was going to be called porting 140,000 lines of code from Python 2 to Python 3, but then we looked in the subdirectories, and who knew? There was a bit more. So in case you haven't heard, it's even worse than we thought. It's dying on the 1st of January, not whatever date in April everyone originally guessed. We have our commercial software, Miro, which is 300,000 lines of code. Worse than that, it's not only Python 2, it's got UTF-8 in the middle, not Unicode, so things are really, really, really bad, or at least they were. Our goal, we decided slightly suicidally, was to have a single code base that would run in Python 2 and Python 3, and not only that it would run in Python 2 with Unicode literals or with bytes, and we've actually managed to do that, which is pretty fantastic, which means we can start ripping out all the stuff now. I would say the most important thing we had was a big set of tests. We had about 1,600 tests with about 10,500 assertions in them, so that was a pretty good start. So we tended to know whether things worked. Basically, none of them worked as soon as we shoved it into Python 3. First thing we did was put all the future imports except the Unicode one in, and that's obviously a good start. We had the division one there anyway, but that bloody print function and stuff we needed to sort out. We had code to toggle whether or not we were using Unicode literals, and that was really the first thing we tackled, trying to make that work. That obviously is one of the really hard bits in the Python 2.3 transition. You discover lots of things along the way. You discover that Python 3 is much fussier about nulls in lists, non-values in lists, and you have to get rid of them. You can't do comparisons between null values and numbers in Python 3, which is a thoroughly good thing, but if you've got code that does it, you need something like this, some kind of helper function to deal with it. We have loads of declarations all over the place that are checking whether we're Python 2 or Python 3 and making everything available in both. So we need the bytes type available, we need the Unicode type available. And then we have lots of functions for forcing things to be either Unicode or UTF-8 definite at different types according to what we need them, according to whether we're doing I/O or not. We have, I'm not going to go through them in detail, but we have SCADSA functions for forcing things to be into Unicode or into UTF-8 or into whatever our native internal implementation is or into whatever not our internal implementation is. It's all very tedious. So we have the types. Longs and ints you have to worry about because the long type goes away because ints are longs in Python 3. Sorry, I'm sounding like I'm complaining, but it's all very annoying when you're doing the port. It turns out that things have moved in the CGI and URL libraries that we use quite a lot, so you have to have conditional imports for that. Tiny little things have changed, like when you print an escaped string, like a regular expression, it turns out you get an extra backslash in Python 2 compared with Python 3. Who knew? Who cares? Well, it messes up your tests if you're testing that kind of stuff. One of the big things, obviously, you'll know about is a lot of things that were lists in Python 2 are generators or iterators of some sort in Python 3. And that means that you, in particular, can't loop over dictionaries and change the contents as you're going, which is always kind of a dangerous thing to do anyway, but it doesn't work in Python 3. So the quick hack is to listify lots of things, but the better thing, obviously, to do is to actually benefit from the fact you're using generators if you possibly can to avoid blowing them up. Numerical precision has changed for printing in Python 3, so again, that'll screw up your tests if you don't use it carefully. My God, I've got through 4 minutes already. The .next method has gone on iterators, so you actually have to use next on the iterator instead, which is fine, but you have to do it. Dummy variables. Yes, one of the really super annoying things in Python 2 is that if you use a dummy variable in a comprehension, it's still defined after the thing, so you can screw up real variables. That's gone in Python 3, which is fantastic, unless, of course, you depended on the fact that you could still read it afterwards. Pickles are not really compatible between Python 2 and Python 3. You shouldn't be using them for anything except very short-term storage anyway, but we were, so we switched to JSON. It turns out it's not only more portable, it's much faster as well, so God knows why we weren't doing that anyway. Last couple of comments. We, in doing this, didn't use many of the conversion tools, but we did use PEP8 and PyFlakes and our very own TDDA library for checking an awful lot of stuff. We used Pylint and coverage.py a little bit for checking things. At large scale, we didn't find 6 or 2 to 3 helped at all. I'm not saying they're bad, just we didn't use them. These slides are available. They're from the Edinburgh meetup at that URL there. That's me. Thank you for your time. Hopefully that helps someone. There.
James, you know you're up after this, right?
Hello everyone, this is Amit, and I'm going to talk about yet another Python conference. So this is PyLondinium, which is happening this summer from 8 to 10 June, and for the support of PSF. And the tickets are ready for sale, and tickets are really cheap. So if you can afford PyData, you can really afford this. And it's for the community, and so all the money generated from the tickets would go to PSF directly. We got some really amazing speakers. Naomi, the chair of PSF directors, and Daniel, the core contributor to Django. Ian, you have already heard him, the co-founder of PyData London. And then we have Victor Stina, the C Python core developer. And here's the schedule. If you wanted to talk, then you already lost a chance. And the venue is London itself, in the Bloomberg's office. Big shout to them, Bloomberg. And that's it. Thank you.
So this is my 5th year at PyData London. It's the 5th time I've been giving lightning talks in front of all of you. I think so far it's been an absolutely amazing event. For those of you who don't know me, I'm James. I'm a volunteer at NumFOCUS. I've been volunteering with NumFOCUS for 6 years. And I keep doing it because it's worthwhile. If, having seen how well run this event is, you would like to run a PyData meetup or conference in your own city or your own locality, please come let us know at the NumFOCUS booth. Come talk to me. You can see this conference has absolutely been fantastic this year. It gets better every single year. I think we should give the organizers, Florian and Marco, recognition, as well as Cecilia, recognition for their hard work here. So let's give them a round of applause. And for those of you who aren't from London, I would love to talk to you about doing something like this where you're from. So come talk to me. I'm James. I'm with NumFOCUS. And let me get into my lightning talk. So my lightning talk, I didn't have a whole lot of time to prepare this because I was preparing the pub quiz, which is coming up shortly. I ran the questions by a couple of people, and they're not too hard. They were really hard last year. So I tried to go a little bit easy on you, but it's kind of fun. There'll be some good questions. For the lightning talk, I wanted to talk to you about a PEP that a lot of people kind of missed. And when I talk to people about this PEP, they don't quite get what it's all about. This is PEP 551. It was put together by Steve Dower, who's one of the chairs for PyData Seattle. And if you scroll to the very bottom, it's a fairly long PEP, but it's pretty straightforward. You can see that I was marginally involved in its development. You can see my name here all the way at the bottom. Let me explain it to you. And it's something that's actually, people look at this and they don't quite get it, but if you explain it the right way, it makes sense. This is about adding certain features to the Python interpreter, namely security transparency. And security transparency, I'll give you a scenario where it'll just make sense. Imagine you have either some Windows machine or some Docker container running an application. If it's a Docker container, it's running that application as PID1, meaning there is no need for anything else in that container. You don't need a Python interpreter unless the application is running Python. You don't need a shell. You don't need a compiler. You actually have an environment which has restricted computation. You can't just run arbitrary code in this environment because you can strip it clean of everything. If it's a Windows machine, you can go even further because Windows has tools like device guard. So you can't take a Windows machine and just run an exe if it's not signed, if device guard is enabled. Well, imagine that this container contains maybe a database or a data source of very private data. And your fear is that somebody might get into that container or into that VM. Once they're inside that VM, they'll use Python, if there's a Python interpreter in that VM, to bring down malware, and they'll start exfiltrating data. So you might have financial data, health data, personnel data that's very valuable there. And if there's a Python interpreter inside that virtual machine or inside that container, it can be used as an exploit to pull data out. Now, one of the problems is if you eliminate Python and you only run compiled applications, that's fine. But we love using Python, and the whole process for compiling Python into EXEs is kind of a mess. People have been trying this for a long time, but even with the production pipeline, the deployment of it's kind of messy. So PEP 551 is the idea that you can take a Python interpreter, we can add certain things to that interpreter to not only lock it down, but also to provide security transparency so that if you have here's our Slack channel, so that if you have a Python interpreter that has, a Python interpreter, you can at least check to see what's going on inside the interpreter. You can add logging hooks so that you can at least see somebody's trying to break into this machine or somebody's trying to use Python on this machine to pull malware in to exfiltrate data. One of the things that I worked on for this is trying to, as the PEP says, I worked on some of the initial implementation details, and then I thought, wouldn't it be fun to popularize this idea, if anybody wants to use it, to see how I can break it. So I want to show you, in the remaining minute or two that I have, one really neat thing that we discovered in working through this PEP. One problem is, if you have code signing, you have a Python interpreter that can only run signed code. And so you're done. If you don't have a signing key to sign the code, you can't run it in the virtual machine. But there are a couple of very easy exploits. If in one of the previous talks, Nick, I believe, talked about not using pickle because it's not stable between Python 2 and Python 3. If you care about security, do not use pickle. Pickle basically opens a hole in your Python interpreter to run arbitrary code. There are other ways to get arbitrary code execution in Python. There's one thing that we found that was very interesting. What we found is when you have something like a variable in Python, and you do something like x equals 10, x plus 1, and you disassemble it, you can see there's this load fast operation. This represents how Python pulls in a local variable. how it loads a local variable onto its stack. If you look at the bytecode for it, you can see it calls this macro getLocal. If you look at this macro getLocal, you can see it does an array access that's unbounded. So what we developed were a couple of techniques by which you can create poisoned bytecodes that tell your load fast to load a local variable that doesn't actually exist so that you can get unbounded memory access into your Python interpreter. Once you have that technique, it becomes very easy to do things. One of the things that we're working on right now is you might not be able to write to an arbitrary location because of memory protections. For example, if you look at your proc file system, you can see that the way that memory is orientated on Linux, you have these different pages representing the different parts of your program. You can see here's the cat, here's the libc, and some of these are marked as read or write only. And you might only be able to reach into a read-only page, and you won't be able to write there. But using this technique, what you can do is you can spawn Python interpreters. You can fork exec to spawn child Python interpreters and just have them read sequentially through memory until they fail to start mapping out what memory looks like. You don't know anything but have the ability to run poison bytecode through a poison pickle object, and you can start scanning through memory. Once you do that, you can find a page that you can maybe write to. And what you can do with this is because you can write to arbitrary parts of memory and load them up, we've already been able to make tuples mutable. That's actually fairly easy. I'll show you the gist for it. It was actually fairly easy to make tuples mutable. And it's a little hard to get Joe's Twitter handle right. But we'll see, where is it? Mutable tuple. That's the first thing. And the second thing that we're working on right now, here's tuple set item using this approach. We create a poison bytecode and then a couple of generators, and in the end, you end up being able to change the contents of a tuple by just writing directly to that memory. The other thing that we want to do is we want to take a C extension in a string, pull it into the Python interpreter by writing it to arbitrary memory locations, and then lift that into the interpreter by telling Python it's an actual Python object, by loading into it using a poison bytecode. And Python doesn't know, are these valid Python objects that I've allocated or not? So you can just take a string that contains some really nasty payload and do that. The reason for that is when Steve was working on this, he said, I can't get people interested in this. Can you come up with a way to do a meltdown or Spectre hack using Python and this PEP? And that's the best we can do. So hopefully by next year we'll have a meltdown or Spectre hack using Python on a lockdown machine. But I did want to genuinely bring the attention of PepFit 551 for you, because if you work in a healthcare company or a financial services company, you may actually have machines which allow attackers to come in, bring malware in, and start exfiltrating data. And in those cases, that's quite a serious problem. The use of Python there is actually opening up a serious hole for you. And so hopefully you have a look at this PEP. And if you'd like to talk about it or like to talk about ways that you can secure a Python interpreter in production to avoid these, please come see me. Thank you so much.